Okay, hi again everyone, and welcome back to our statistics class notes. We're now on page 119 in section 8.1, where we're introducing the ideas of hypothesis testing. So we're now at the point of where we've computed a z-score, a z-statistic, a test statistic, and we want to be able to see if that test statistic is enough information to reject the null hypothesis and say that it supports our alternative hypothesis or not. Okay, so what we've done is we computed a test statistic, which is a z-score, and then the p-value is the probability of getting that z-score or one more extreme further away from the mean. So that p-value will be really close to 0 if our test statistic is a long ways from the hypothesized, the null hypothesis, the p-naught, which we thought was the middle of the distribution. If the p-value is big, then it's going to be close to the null hypothesis, the test statistic will be, and thus we won't want to reject it. So we're going to have a systemized way. We're going to choose a significance level. Typically, the typical one is an alpha of 0.05. So if the p-value is less than that alpha, whatever alpha we choose, we can go ahead and reject the null. If the p-value is greater than or equal to the alpha, we do not reject the null. Okay. Now, on this example of global warming, so right here, when we compute our test statistic, we got 8.28. This middle 0 now, when changed to a z-score, that's where p-naught was. That's the null hypothesis. So our test statistic was 8.28 standard deviations above that null. Okay. Now, that's where it would lie on this axis. So based on the graph and what we know about z-scores, what do you think the probability of getting a test statistic at least as extreme as the one we calculated? So in other words, the probability of getting a test statistic of 8.28 or more. Well, that's certainly going to be about 0, right? That's the area and the tail to the right, more extreme. If we use a StatCrunch normal calculator, which I won't do right now, but you all could do that, put in a mean of the p-naught, which remember was 0.55, put in your p-hat, which was, put in the standard deviation, which is p-naught times 1 minus p-naught over the sample size of 1,000, take the square root, and then say what's the probability of getting a test statistic more than 0.68. Or if I change them to z-scores, do a mean of 0, standard deviation of 1, and say what's the probability of getting z more than 8.28. That comes out to be 1.1 times 10 to the minus 16, which is 15 zeros after the decimal before you get 1, 1. So that's certainly really close to 0, much less than if I had chosen alpha to be 0.05. So that's very strong evidence to reject the null, because z equals 8.28 is a very unlikely test statistic if the null hypothesis were true. So can we conclude that the percentage of Americans who believe that global warming is caused by human activities increased from 2015 to 2017? Well, let's explain. What we can say is, this is how you should always start to interpret things. There is sufficient statistical evidence. Sufficient is just a fancy word for there is enough. There is sufficient statistical evidence to support the conclusion that the percentage of Americans who believe that global warming is caused by human activities has increased from 2015 to 2017. So in other words, there is sufficient statistical evidence to support HA, the alternative hypothesis. So we have evidence, so since the p-value is really small, less than alpha, we can reject the null, which means there is sufficient statistical evidence to support the alternative, which in this case is the percentage of Americans who believe global warming is caused by human activities has increased.